Hello, class. So today we are doing our last bit of learning on problem solving. So we're doing two different types of questions today. One will involve kind of bridge questions or landmark questions where the actual arch is shaped like a parabola. And the other is completely different. It's about revenue. So I'll get to that when we get there. So this first example is about the underside of a concrete railway pass, and it forms a parabolic arch. The arch is 30 meters wide at the base and 10.8 meters high in the center. The upper surface of the underpass is 40 meters wide. The concrete is 2 meters thick at the center. Can a truck carrying a special load that is 15 meters wide and 7.5 meters tall get through the underpass? So this is quite a daunting problem if you look at it just as a bunch of words. So the first thing we're going to do is draw what this bridge looks like, and then we'll go from there. So that's the very first step I would always suggest. Step number one is to do a sketch. Okay, so the arch is 30 meters wide at the base. So we often might think to start at 0 and make it go up to 30 meters wide, but I'll tell you a trick. With these questions, it's best to make the center of the arch on the y-axis. So because it's 30 meters wide, that means going 15 meters out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15. And 15 meters the other way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, you know what? I think I actually am going to do this. I'm going to go up by 2s. So this is 2, 4, 6, 8, 10, 12, 14. So 15 is halfway there. And then negative 2, 4, 6, 8, 10, 12, 14. So that's negative 15. So this is the point 15, 0. And this is the coordinate negative 15, 0. Okay, and then we know that it is 10.8 meters high. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.8. We can eyeball that. So that coordinate is 0, 10.8. Okay, so this arch is there then. Okay, it's hard to know, it's tempting to kind of just draw it really linear, but remember a parabola forms a nice arch like this. So do your best to represent what a parabola would look like there. So that is the parabola part. Not the greatest drawing, but I did the best I could. It says the upper surface of the underpass is 40 meters wide. And the concrete is 2 meters thick. So that means the concrete goes up to 12.8 and then 40 meters across. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So over to 20. Oops, that'd be a bit higher. And then to negative 20. Okay, so that is the very top of the bridge. Okay, and then it would come down here. So the actual bridge part, to be honest, doesn't really matter. It's just to help you draw a picture. Really, the only part we care about is the parabola. So what they're saying now is, can a truck carrying a special load that is 15 meters wide and 7.5 meters tall get through the underpass? Can it fit through here? So another way of phrasing this is, if you go 7.5 meters up, is it wider or less wide than 15 meters? That's how I think of this. Now, alternatively, you could say, well, 15 meters wide, how far up does it go? But I like to think about this as, how wide is the parabola when the height equals 7.5? Okay, so if it's greater than 15, then it can fit through there. And if it's less than 15, it can't fit through there. So if we go up to 1, 2, 3, 4, 5, 6, 7.5, it's basically saying, how wide is it here? So here's our width going one way, and then it would double going this way. So we'd have to add those two together to find out what the width is. So how can we actually find this? Well, we need an equation for the parabola. There's no other way around it. We need an equation for the parabola. Then once we have that equation, we can set it equal to 7.5 and solve for W to see how wide it is. Okay, so let's go ahead and do that. So we can create an equation in factored form or in vertex form, either one. I did mine in factored form, so that's what I will show you, but doing it in vertex form does work as well. So let's say let W represent width in meters from the center of the arch. Okay, it's important that it's from the center. Okay, that is a key point to include here. And we'll say let H represent the height of the arch in meters. Okay, so our height is equal to some A value, which we need to find. And then our factors are W plus 15, W minus 15. Okay, those are our x-intercepts. So we can put it in factored form like that. And we need to solve for A. So in order to solve for A, we need to sub in a point. So now I will sub in 0, 10.8 to solve for A. All right, so you get 10.8 equals A, 0 plus 15, 0 minus 15. So 10.8 equals A, and then 15 times negative 15 is negative 225. So when you divide both sides by negative 225, you get an A value of negative 0.048. So because this is a word problem, it's fine to leave that as a decimal. Okay, and don't round to negative 0.05. You would get too much inaccuracy with that. Okay, so then we get that our equation is H equals negative 0.048, W plus 15, sorry, I keep getting that, W minus 15. Okay, so in order to solve this, we will actually need this in standard form. So I'm going to expand these brackets, okay, because it's a difference of squares. You get W squared minus 225. And then I distribute that through, so you get negative 0.048 W squared plus 10.8. Okay, now notice that this is actually also in vertex form because the vertex is 0, 10.8. So is the y-intercept. So this should make sense to you that this represents the same parabola and that it's exactly 10.8 there. See, if you had rounded this too far, you wouldn't have gotten the exact 10.8. Okay, so now I need to find the width of the bridge when we are at 7.5 meters high. So I'm going to take my equation of the width of this the height, sorry, of the parabola. So that represents the height at any given width. And I'm going to set it equal to 7.5 to see what the width is there. So we can actually isolate W in this case because there is not a W squared and a W. There's only a W squared. So we can actually isolate W. Alternatively, you could move the 7.5 to the other side and use quadratic formula. It's just that your B value would be 0. So that is doable as well. Both completely fine ways of solving this. So I just moved this 10.8 to the other side to get negative 3.3. And then I divided both sides by negative 0.048, and I got 68.75. And when you take the square root, I got plus or minus 8.29. Okay, so if you get back up to our parabola, that means that it's 8.29 in this direction and 8.29 in that direction. So the total width then is 2 times 8.29, since you have to go in both directions. So it's 16.58. So therefore, the answer is that yes, the truck would fit in, since the truck is only 15 meters wide and there's 16.58 meters of space. It's going to be a bit of a tight fit, but technically, yes, if it goes right down the center, it will fit. So obviously you should write a thoughtful sentence here about your reasoning. Okay, you could think about some ways that you could add sprinkles to the end of that question. So one way to add sprinkles would be to say how much room there would be on either side. So 16.58 is 1.58 larger than 15. You divide that by 2. It shows you how much room you would have on either side. Talking about how important it would be to go right down the center of the parabola. Lots of little ways that you can add understanding and showing that you're connecting the math to the actual situation. And that's the kind of place to get level 4s in your thinking and your application marks. Okay, so now we have this rainbow bridge in Utah. And it has an approximately parabolic in shape. The arch is 88 meters high and 84 across. So again, we can just draw a really basic sketch of this. It really helps to envision what's going on. So here is our arch. So we know that it's 88 meters high. So again, I like to do the vertex on the axis because it makes for just simpler formulas. And 84 across. So 84 divided by 2 is 42. So this would be 42, 0, and this would be negative 42, 0 to get a total of 84 meters across. Determine a quadratic relation in standard form that models the shape of the arch. So again, remember, if you want something in standard form, you have to do it in vertex form or factored form first, and then convert it to standard form. So in this case, just to show you something different, I will first create the the equation in vertex form. So my HK, the vertex that I've chosen here, is 0, 88. So my equation would be y equals a x minus 0 squared plus 88. And then I can sub in another point. So I'm going to sub in 42, 0 to solve for a. So I get 0 equals a times 42 minus 0 squared plus 88. Okay, so now I need to isolate a. So I move the 88 to the other side. Okay, 42 squared is 1764. Divide both sides by 1764, and I get that my a value is negative 0.05. Okay, so that means in vertex form, my equation is y equals negative 0.05 x squared, because it's x minus 0, so I can just put that to x squared plus 88. So actually, because the vertex is on the axis, by putting it in vertex form, it actually already is in standard form as well. That will happen when your vertex is on the y-axis. Okay, and now notice that you didn't identify your variables yet. Okay, in a word problem, you always need to identify your variables, even if they're x and y. So you could change this to h and w if you wanted. I'll just leave it as x and y. So we'll say let x represent horizontal distance from center in meters. Okay, I want you to think about why it's so important that we say it's horizontal distance from the center. That makes a big difference because that means that negative solutions for x are fine. It just means it's to the left of center. And it also means that any x values greater than 42 are not admissible. So it really is important that you're very specific about if you mean from center. I also want to take a moment to just explain that if you did draw your, oops, didn't mean that to be so thick. If you did draw your arch like this, so starting from the origin and going like this, you could still get all the correct answers. It's just that your quadratic relation would look different. The equation would be different. And then you would put in different information for the width and all that kind of stuff. So this is still acceptable. It's just the methods that you would use to find the, how tall is the arch 20 meters from one side, you just would be putting in different x values. So I tend to suggest to students to just always draw it this way since that's how I present it to you. But if you want to play around with it and try this representation, by all means, go ahead. So how wide is the arch at half of its height? So basically, that's just saying at half its height, how wide is it? So half the height, well, it's 88 meters high, so half the height is half of that, which is 44 meters. So we need to figure out what x values give a height of 44 meters. So we take our equation for the height, and we set it to equal to 44. This will tell us what x value we get when the height is at 44. So again, I don't need to use quadratic formula because I only have an x. So I can actually isolate x. So my first step is to move 88 to the other side to get negative 44. Divide both sides by negative 0.05 to get 880. And then I take the positive and negative square root. So I get positive and negative 29.66. So that means it's 29.66. This point here would be 29.6644. And this point would be negative 29.6644. Okay, so then the width is double that, because I have to go in both directions. So we get 59.33. So then you can put a nice little sentence, something like, therefore the width is 59.33 meters at half its height. Okay, how tall is the arch 20 meters from one side? So, oops, let me just draw this here for you. Again, just so I don't have to keep scrolling up. So be careful about what this means. 20 meters from one side is not 20 meters from the center. It's 20 meters from here. So if this is 42 meters, then we're looking for the height at 22 meters. So at 22 meters, what is the height? That's what we're solving for. So be careful that you're not putting in 20, but you're putting in 22. It's from the side, not from the center. Okay, so if you think about this, we know that it's going to be a little bit higher than above, but we'll see. So we just need to find our height when our x value is 22. So this is actually much simpler than part B because we're just putting 22 into the equation. So when you do that, if you put this into your calculator exactly as it's written with all the brackets and everything, you'll get to the correct answer, which is 63.8 meters. So that's how tall it is, 20 meters from one side of the arch. So you can put a nice little sentence there, again, explaining that. So that is our work on arches. And landmarks and bridges, I'm going to do a separate video on revenue just because it's such a separate concept and you might want to rewatch them separately. So that'll make it a bit easier for you to find what you need. So thanks for watching. Hope you learned lots.